Now we're going to look at using an approach we call the Skill-Brodmann method, and it can be used for creating virtual EEG waveforms and for neurofeedback training, as well as for imaging. So first we want to review that we are currently looking at a live S-Loretta projection of brain activity. This is the client's EEG here, and we see the characteristic waxing and waning patterns of the signals coming and going. And in particular, because this is an alpha-rich recording, we look at P3 and O1, where my mouse is right now. P3 is up here, O1 is here. And then down on the right-hand side, we have P4 and O2 here. And you can see that there's a predominance of activity at P3, O1, and at P4 and O2, so that we also see in the Loretta that there's a posterior source here. There's a posterior dominance. So it would be interesting, in order to train these specifically, to look at the ability to get waveforms and training channels which are related directly to these brain regions, rather than simply to the electrode locations, such as P3 that we see here. P4 is over here. Now, in order to do that, one method we use is called Brodmann localization. And let me briefly show how that works. Brodmann was a neurologist in the 19th century who developed an understanding of the structure of brain cells under the microscope. And by using differences in those structures, he created regions that he numbered and named, basically. And here we see Brodmann areas by number. 1, 2, and 3 are in this postcentral area, anterior parietal area. 4 is on the motor strip. 5 is sensory. Then we see Brodmann areas 6, 7, 8, and 9 in the frontal areas, etc., etc. 10, 11 are frontal, and it goes on from there. There are in excess of 40 individual Brodmann areas. This map shows it going up to 46. And most notably, for example, areas 17, 18, and 19 are visual primary areas. And on an interior view, then, we can see also, for example, 17, 18, 19 being association areas. Here's area 7, 1, 2, and 3, 4, etc. And we're going to use these numbers in order to control the software, in order to decide which parts of the brain we want to look at. So the example we're going to look at is going to be area 19, for example, right here, where we see this is the secondary association area for visual processing, and it's also very dominant in this person's alpha. So what we can do then in the software is to select training channels that look at these Brodmann areas. So for example, if I were, as an ROI in the user interface, to choose that, I would go down to Brodmann here, and I would move on down until I know I'm in the right area, and then I would select here, and now we have Brodmann area 18, and as you see, it's this posterior parietal area primarily. It happens to be a dominant source of activity for this client. So for example, we may want to say I only want to look at the left, and now we're looking at left area 18, and we see the alpha activity coming and going. And then we can switch to right area 18, and here we see there's somewhat more alpha activity, as we saw previously. Now, in neurofeedback training with this, one would typically want to train at P3 or P4 in order to get access to the activity. And what we're going to do instead is use Brodmann training channels in order to actually acquire this activity as part of the signal, as actually a training channel. And in order to do that, what we do is go to the setup screen. We go to Viewer Change Settings, and then what we're going to do is done in the montage editor, because it's in the montage that we include these skill regions of interest. So what we see in the montage editor is that we've set up 4 channels, and those channels have been set up in order to illustrate this skill region of interest Brodmann training. So what we've done is the first channel is P3, reference to linked ears, and we label that P3, so that's a standard surface channel. And the second channel is actually area 19 on the left side. So it's Brodmann area 19, and we use this equation then. We check the equation box and select and type in skill, R-O-I-L for left, and then parenthesis 19, parenthesis, and then a semicolon to select that skill region of interest for that channel. Then the next channel is P4, reference to linked ears, typical. We label it P again.
Both cameras were recording, sound was working.
Now there's another thing I could put, skill R-O-I-R 19. So this becomes our montage, and these channels now, being training channels, can be trained using amplitude or coherence training as if they were any other typical training channels. So to illustrate how this looks then, we'll go to this display here. Remember, tab 1 is our raw waveforms. We've set up tab 2 to be the training channels. So here we have the training channels, and we're showing the alpha. And what we have then is P3 on top, and then area 19 on the left is actually channel 2. Then channel 3 is P4, and channel 4 is area 19 on the right. And what we're looking for is more clarity of bursting here on channels 2 and 4, and we see that here. Very much on channel 4, we see that often it's giving bursting activity when it's not that evident in P4. P3 and P4, being surface channels, are commingled with a lot of other spread information, and the Brodmann channels, channels 2 and 4, are much more specific. So they're drawing data directly from the involved regions of the brain, and now we see much more clearly that we have this specific activity on area 19 on the right, which is much more different pronounced from the activity on the left, area 19 on the left. So this shows that using Brodmann channels to separate brain activity can give you more specific information, better resolution in time as well as in space compared to surface training.